Hey everyone. So in the previous video we were talking about the addition of steam. We know that when alkenes react with steam in the presence of phosphoric acid catalyst and obviously at 300 degrees Celsius, the addition of steam happens, which means the double bond goes away. You get one hydrogen atom and one hydroxyl group on the carbon that had the double bond. So one carbon of the double bond gets the H atom, the other gets an OH group. And this is how we thought the addition of steam happens. We did see at the fact that alkenes react with steam to make alcohol because when a hydrocarbon gets OH group, it's not a hydrocarbon anymore, it gets OH group, it becomes an alcohol. For example, propene can make a propanol molecule by the addition of steam, butene can make a butanol, so on so forth. Similarly, using the same ideas, we're going to jump off to some past paper questions and we're going to see how the paper 1 practice can be done. So today's video is going to be dedicated to some past paper questions. We're going to try our best to see how we can solve these questions. So let's look at these questions. It says, the diagram shows the structure of the compound 1,3-butadiene. So I know the fact that buta means 4 carbon and diene is something new for us, but it indicates the idea it's a double bond. Buta means 4 carbon, ene means carbon carbon double bond. It says how many, let me get the red line here. How many molecules of hydrogen are needed to saturate one molecule of 1,3-butadiene? So how many molecules of hydrogen do we need? If I'm not wrong, I can see the fact that there are 2 double bonds, one over here and one over here. One hydrogen atom is going to come over here on both these carbons, and one hydrogen molecule, obviously, like one over here and one over here. So total 2 hydrogen atoms are going to come over here. So we need one hydrogen molecule plus another hydrogen molecule, because from one molecule 2 atoms go on each carbon and the other molecule will provide 2 atoms going on each carbon. So we need a total of 2 molecules of hydrogen. We need 4 hydrogen atoms, you can say, and we need 2 hydrogen molecules. Let's look at some other question. For example, let's say, yeah, a vegetable oil is polyunsaturated. If I'm not wrong, the word poly means many and unsaturated means carbon carbon double bond. So poly is equals to many, and unsaturated means carbon carbon double bonds. So polyunsaturated compounds mean they have many carbon carbon double bonds. Which statement about this vegetable oil is correct? It has double bond between carbon and hydrogen atoms. No, sorry, there are no double bonds between hydrogen atoms, never. It reacts with hydrogen to form a solid compound. I know that unsaturated compounds do react with hydrogen in a reaction known as addition of hydrogen, and when addition of hydrogen happens, they make alkanes. Which are saturated compounds. But let's park it and let's see other options. It reacts with steam to form margarine. No, sorry, when it reacts with steam it forms alcohol, not margarine. We did see it in the last video that alkenes react with steam to make alcohol, not margarine, something. So option C is also incorrect. It turns aqueous bromine from colorless to brown. Again, that is incorrect. If you guys remember, when alkenes react with bromine, they decolorize it. Decolorization happens, so it becomes brown to colorless, not colorless to brown. So it's saying colorless to brown, which is incorrect. Actually, it happens brown to colorless. This is the correct order of the color change. So this is also incorrect. So B for ball is the right answer, because when you make alkanes have higher melting and boiling point, so they become solids. Let's look at more options over here. Yeah, this one is really interesting. What is the structure of the product? So they're asking for the structure of product of the reaction between butene and bromine. So they're talking about addition of bromine over here. They're talking about addition of bromine. If I am not wrong, in addition reaction, the carbon-carbon double bond goes away and two bromine atoms join it. How do we find the structure? Guys, now it's really important for us to see. If I were to highlight all the 4 carbon atoms with different colors, let's say carbon 1, carbon 2, carbon 3, and carbon 4. If I have 4 carbon atoms, the double bond is right over here between the carbon on the red and the carbon on the fourth. You can see if I call it 1 and if I call it 2, I have the double bond between carbon 1 and 2. My bromine atom are gonna come over here and over here on carbon 1 and 2. Between the red and the blue, the double bond goes away. The red carbon atom gets one bromine, the blue one gets another bromine atom. Using this fact, I need to know where the structure lies. So I can clearly see this is not the answer because it has one bromine over here, another over here, which is incorrect. B also seems to be incorrect because it has one bromine over here, another is so far. C also incorrect because it has one bromine on carbon 1 but another is so far away. D seems to be perfect because it has one bromine right over here on the carbon in the corner, which is first carbon, and another right over here on the second carbon. So the two nearby carbons get it, the two carbons adjacent carbons get it. So D for doctor is the right answer because the carbons on the corner get it and they are adjacent carbon atoms. Guys, let's try this structure. Substance X with the molecular formula C4H8 does not react with hydrogen. So they are saying it does not react with hydrogen. It means it gives no addition. Because if it's not reacting with hydrogen, there is no addition reaction. And if it is giving no addition reaction, that means it is no alkene. Because all the alkenes give the addition reaction with hydrogen. If it's not reacting with hydrogen, I am really sorry, but it's not alkene. What is the structure of X? So they're looking for the structural formula of X. Now I know it has alkene. It will react with hydrogen. I know this has an alkene, so it will also react with hydrogen. I don't see a carbon-carbon double bond in option C, so I'm going to park it. In option D, there's also again a double bond, so it is also reacting with hydrogen. The first two and option D give addition reaction with hydrogen. Option C does not. So option C is not an alkene. It's not an alkene. That is why it does not give any addition reaction. Rather, it's a kind of cycloalkane. It's a kind of cycloalkane, which means it has 4 carbons in a cycle. It has 4 carbons in a cycle, which means it's a cyclobutane. It's a cyclobutane. So C is not an alkene. Let's do few more MCQs. We can see over here the structure of 4 organic compounds are shown. Which compound decolorized bromine water? So it's asking for decolorized bromine water, which is something all the alkenes do. All the alkenes do it. They decolorize the bromine water. They turn it from brown to colorless. This is not an alkene. Molecule number 2 is definitely an alkene. Rather, it's ethene molecule because it has 2 carbon atoms. C, option 3, I believe, is not an alkene again. It's rather a propane, which is not an alkene. Option 4 also seems to be an alkene because it has a carbon-carbon double bond over here. And it has 3 carbon atoms, so it would be a propene. It has 3 carbon atoms, I can see. Carbon number 1, carbon number 2, carbon number 3. 3 carbons with a double bond propene. So the correct answer has to be molecule 2 and 4. I can see it right over here. Let's do, I believe, this MCQ. Which molecule does not undergo addition? Does not undergo addition with alkenes. So I remember there are 3 addition reactions. One is with steam, one is with hydrogen, and one is with halogens, for example bromine or chlorine in the aqueous state. So I can see bromine over here, hydrogen over here, steam over here. ammonia does not undergo addition reaction. So guys, let's recall the fact that there are three different kinds of addition reaction for alkenes where the carbon double bond is broken down. Let's recall the facts, and in the next video we will be talking more about the paper 2 practice of the alkenes. So stay tuned guys, you have been amazing.